Welcome! This lesson introduces you to pfSense. pfSense is a free, open-source, feature-rich firewall. Along with firewall services, it also performs a variety of network and security-related functions. Although pfSense runs on FreeBSD, practically all management of the firewall after the initial configuration is done through a nicely laid-out web interface. Initial setup is done with a convenient setup routine. Once you assign the interfaces and, if needed, IP addresses, you'll be good to manage via the web. You can see a complete list of applications and features at pfSense.org. Scroll to the bottom and select Features from the footer menu. pfSense offers you Virtual Private Networking or VPN server, high availability, load balancing, traffic shaping, Unified Threat Management or UTM. Of course, it's a router and a firewall, Domain Name System or DNS and Dynamic Host Configuration Protocol DHCP servers, Intrusion Detection System and Intrusion Prevention System IDS/IPS, a transparent caching proxy, web content filtering, stateful packet inspection, geographical IP blocking, anti-spoofing, virtual local area network or VLAN support, virtual private networking or VPN support with many options, Snort or Suricata-based IDS and IPS, emerging threats database, IP blacklist database, deep packet inspection, open source add-ons, many enterprise reliability and user authentication options, web content filtering options including DNS blacklisting, great web-based configuration and management console, system security options, and copious reporting options. Many enterprise products from companies like Cisco, Juniper, Fortinet, WatchGuard, and Palo Alto, to name just a few, would charge you huge money to license these features on their devices. Depending on the size of your infrastructure you want to protect, licensing could range from thousands to hundreds of thousands of dollars. Earlier in my information technology career, I installed, configured, and maintained firewalls by several of those vendors for customers as a consultant. Later, after finally learning of the outstanding benefits of open source software and discovering pfSense, I installed pfSense virtual appliances in front of our entire IT infrastructure. Whether you're a home user who enjoys learning about security, a network administrator or system administrator at a small to medium-sized business, or want a flexible free tool to secure your enterprise infrastructure or parts of it, pfSense is worth your consideration. pfSense provides a free firewall in the form of software for your home or office that you can run on old hardware or virtualize, or if you want a pre-installed, cost-effective offering direct from Netgate, pfSense has you covered. I have an SG1100 on its way from Netgate for my home. This would be adequate for a home or a very small office of up to maybe 10 people or so. Maybe you could do 20, but why not go a little bit bigger if you have a small office? If you have a larger office, you could get an SG3100 or SG5100. If you have a large business, consider the fully fledged high availability XG series. In the coming lessons, you'll learn how to download, install, and configure pfSense to protect your home or business. This lesson covers the installation options available to you for pfSense. Whether you want pfSense for your home, small office, home office, enterprise, or the cloud, pfSense has you covered. For home or small office environments, you could install pfSense on some of your old hardware you had lying around in your basement, or you could buy a really low-cost, effective, pre-installed hardware device from Netgate. I just ordered an SG1100 for $159 US to protect my home. To install the hardware, you want to download either the memory stick installer or the ISO image. The USB memory stick installer will let you just install the image to your memory stick, plug that into a USB port on the system you want to turn into a firewall, boot, and install pfSense. The ISO image can be used to install from a CD-ROM or DVD, or it can be used to create a virtualized appliance on a platform that doesn't yet have its own downloadable image, like VMware ESXi, VirtualBox, KVM, Xen, or Proxmox. If your infrastructure is in the cloud on Amazon Web Services or Microsoft Azure, there are pre-built images for you to use to protect your cloud environment. If you want to upgrade a pfSense firewall you purchased from Netgate, you can download a pre-tuned image for your device. I'm not sure what circumstances would lead you to want to do this, as you can just upgrade from the web admin console, but it's an available option. That covers the installation options for pfSense. You could download an ISO image or memory stick image, a cloud-based appliance for Amazon Web Services or Microsoft Azure, or a Netgate optimized image. This lesson covers the minimum recommended hardware for pfSense to run properly. At a minimum, you'll need a 500 MHz central processing unit or CPU with 512 megabytes of random access memory or RAM, but a 1 GHz CPU with 1 GB of RAM is recommended. You can, if you want, use hardware that's almost 20 years old to run pfSense. 1 GHz processors came out in 2000. If you have old hardware, it will very, very likely be able to run pfSense. If this is for home use and you don't mind circumventing your firewall while you look for replacement hardware in the event of a failure, use what you will. If this is for a business, you may want some fairly modern, reliable hardware. pfSense provides some guidance about use of some of the features available that will work better with newer, more capable hardware. Virtual Private Networking, or VPN, to connect to your home or business will require a beefier CPU. If you want to use the captive portal feature, locking down who can do what on your network, that will also require a better CPU. If you'll have large state tables, which basically means you'll either have a lot of users or you'll have a few users with a whole lot of network connections to keep track of, you'll need a beefier CPU. And some of the packages you may want to install will require more CPU and RAM. The Snort Intrusion Detection System, Intrusion Prevention System, or IDS-IPS, is one example. The network interface card, or NIC, you choose is as important as the CPU and the RAM to your maximum throughput. You'll want at least 2 NICs for pfSense to be set up in the most common configurations. pfSense recommends Intel cards or systems with built-in NICs for throughput up to 1 gigabit per second. You may want to learn more about available options if you need throughput better than 1 gigabit per second. As a rough guideline with no packages installed, pfSense recommends the following minimum hardware to produce the desired throughput listed. If you want 10 to 20 megabits per second, an Intel or AMD CPU of at least 500 megahertz is needed. If you want 21 to 100 megabits per second, a 1 gigahertz Intel CPU or AMD CPU is needed. For 101 to 500 megabits, it'll be an Intel or AMD CPU at 2 gigahertz or higher with PCIe network adapters. For more than 501 megabits per second, you'll want a multi-core 2 gigahertz or higher CPU, of course still using PCIe network interface cards. If you're using pfSense to protect your internal infrastructure, including traffic within your wireless or wired networks, you'll want a robust system. For a detailed list of hardware that is compatible with FreeBSD, see the latest FreeBSD compatibility hardware list. Remember that pfSense runs on FreeBSD. To summarize, while you can run on hardware that's quite old, you'll want more modern hardware for corporate systems and for higher throughput, or for using additional features on your device like VPN or packages like Snort IDS-IPS. One way you can set up an entire lab to learn to use pfSense is by using virtualization software like VirtualBox. VirtualBox is maintained by Oracle and is free and available to Windows, Linux, or Mac OS X users. That should cover anyone taking this course. You can download it at virtualbox.org. Virtualization software lets you run an operating system within an operating system. The operating system you will run inside VirtualBox is called a virtual machine or VM. You can download pfSense as an ISO image, then boot your VM to that to install pfSense as a VM. You can also put other Windows or Linux virtual machines on VirtualBox and have them behind or inside your pfSense firewall. You can set all of this up for free, so please give it a try. You'll see how to install VirtualBox on Windows and Mac OS X in the next lesson. The process is very similar for installing on Linux. Don't worry if you've never been exposed to virtualization before and this doesn't make sense to you right now. You'll understand as you proceed through the lessons. Even if you plan to install directly to hardware eventually, please consider learning VirtualBox, as understanding VirtualBox can help you in the future whether you're a home user or an IT professional. You want to install and learn to use pfSense, but you don't have any spare hardware you can use. What to do? Use VirtualBox. It's free software that lets you run multiple operating systems within an application on your existing computer. It's available for Windows, Mac OS X, Linux, and Solaris. That covers any operating system you're likely to be using. Once you've tried a virtual environment, installing on hardware seems slow and painful. Many server infrastructures are virtualized, running on VMware ESXi, Microsoft Hyper-V, or are in the cloud on Amazon Web Services, DigitalOcean, or a similar provider. Taking a moment now to learn VirtualBox increases your options for trying new operating systems and practicing new things yourself, and can make using virtualization software at work more understandable. The operating system you installed the downloaded VirtualBox software to is called the host. The systems you install are called virtual machines or guests. Virtual machines are often abbreviated as VMs. So let's get VirtualBox installed. Download the appropriate package for your operating system from virtualbox.org/wiki/downloads. Once it's downloaded, browse to the file. It will probably be in your Downloads folder unless you typically download to another location or moved it. I'm showing the steps for Mac OS X here, but it will be similar for other operating systems. For Mac OS X, double-click on the VirtualBox DMG file to start the installation process. Your Mac will verify the integrity of the downloaded file. The VirtualBox installation window will open. Double-click on the virtualbox.pkg file. Your system will verify the integrity of the virtualbox.pkg file. A window will open asking you to run a program to determine if the software can be installed. Click on Continue to continue the installation. In the Install Oracle VM VirtualBox window, click on Continue. Enter your username and password if prompted, then click Install Software. If the installation was successful, click on Close to close the installer window. Under number 2 in the VirtualBox window, double-click on the Applications folder to open it and browse to VirtualBox. Double-click on VirtualBox to launch it. You can also launch it from Launchpad. For Windows, double-click the executable you downloaded and follow the default installation prompts. Then open it as you would any other application. On a Windows install, consider right-clicking the downloaded executable and installing it as administrator. I haven't had it happen myself, but I had one student report a grayed out permission when he was trying to select a certain network setting. Installing as administrator will minimize your chances of encountering this error. In this lesson, we'll install pfSense as a virtual machine on VirtualBox. Let's do this step by step. Go to pfSense.org/download. In the Downloads dialog, select AMD 64-bit, select CD Image ISO Installer, and select the mirror that's closest to you. Mirrors are just sites that have the same content hosted in multiple locations, so you can pick one that's geographically close to you. Then click on Download. This will typically download to your Downloads folder. You'll have to extract the ISO file after you download it. Once the file is downloaded, go to the folder where it was downloaded, typically your Downloads folder. Right-click on it and extract the file. On a Mac, you can do this just by opening it with the Archive utility. And there it is. I have another copy, so it's showing as one. Once you have your ISO file downloaded and extracted, open VirtualBox. Click on New. Type in a meaningful name for your new VM. Select BSD for the type and FreeBSD 64-bit for the version, and click on Continue. If you have plenty of memory, I recommend putting at least 2 gigs or 2048 megabytes and clicking Continue. Create your virtual hard disk now. Leave VDI selected and click Continue. Leave dynamically allocated and click Continue. This means the drive will be small and it'll only hold exactly what it needs to, but the operating system will think the full space is there. It'll just grow as it needs to. It'll save space on your hard drive. You can leave these at default, so 16 gigabytes and pfSense for the name of the storage. Now it's there, but we have to change some settings before we try and boot to it. So right-click and go to Settings. First click on Storage. Click on the DVD drive. Choose your pfSense downloaded image. You may have to browse to that by clicking Choose Optical Disk File and browsing to it on your operating system. Then click on Network. I set my adapter to bridged adapter. I have easier setup that way. It's up to you. You could leave it at NAT and see how that works for you. And also configure a second adapter. We need 2 network interface cards for a firewall. The other one is going to be internal network. Then click on OK. Then we double click to boot our new virtual machine. You'll see some text scroll by as the operating system installs. When it says pfSense installer, just hit Enter to accept. Leave Continue with Default Key Map highlighted and hit Enter to select. Or you can scroll down to a different type of keyboard and hit Enter to select that. Leave Auto USF Guided Disk Setup selected and click and hit Enter for OK. Here we're going to exit to the shell. And we're going to say shut down -H now to shut down and halt now. So when it says the operating system has halted, press any key to reboot. Hit the command key if you're on a Linux, the left command key, to get your cursor back. Or if you're on a Windows, hit Control and Alt and let go, and then you'll get your cursor back. At the bottom of the screen, you'll see a little DVD. Click on that and click Remove Disk from Device. If you didn't do that step, when you reboot, you'd go through the install routine again. So we'll press any key to reboot. Just let this time out, or you could hit 1 to enter multi-user mode. And when you get to this screen, you're done for now. We want an operating system with a graphical user interface, or GUI, to be available to manage pfSense. I'll show you how to install Ubuntu Desktop to fulfill that role. You're free to use any virtualization software you may want. VirtualBox is free and it's available for Windows, Mac OS X, and Linux, so that's why I chose it. I'll start with a description of the network topology I'll use. I'll have pfSense configured with 2 virtual interfaces or virtual network interface cards. One will be bridged to my computer's network. You could use NAT if you prefer. And the other will be on the internal network. The internal network will only be visible to other systems added to it within VirtualBox's network. The bridged interface will be the WAN interface, and the internal network interface will be the LAN interface. This matches the configuration from the Installing as a Virtual Appliance to VirtualBox lesson. This will have just one network interface on the internal VirtualBox network, so it will have to go through pfSense to get to our host network or the internet. You may want to use a Windows VM if you prefer. You can download a Windows VM from the link in the References section. Now we'll download Ubuntu Desktop and install it as a virtual machine for use in our lab. So go to ubuntu.com/download/desktop and download Ubuntu 18.04 LTS. LTS is for long-term support. Remember where that's downloading to, because you'll need that ISO file later. I'm going to cancel because I've already downloaded it. Now open VirtualBox and we'll create a new virtual machine. Give it a reasonable name. It's already got Linux selected and it's got version 64-bit, which is what we want. We'll click Continue. Set memory to 2048 minimum, if you have enough memory to do so. We'll leave this at default and click Create and Continue. Dynamically allocated, Continue. We're going to set the size at 20 gigabytes. We'll right-click and go to Settings. Under Storage, we'll have to select our Ubuntu 18.04 desktop. If it's not listed there, you'll just click Choose and browse to it. And under Network, we're going to select Internal Network. This will let us talk to our firewall over the same internal network. Then click OK. And then double-click to start our VM. When you get to this screen, select Install Ubuntu. And then its defaults pretty much all the way through, unless you have to change something because you have a different language. We will choose minimal installation because all we really need on this VM is the web browser. We don't need all the utilities and Office software and games. And we'll save some space by doing a minimal install. So we'll choose that, click Continue. We're going to use LVM because we like LVM. It's Logical Volume Manager. Click on Continue. Hopefully your time zone's right. If it isn't, please just click in the appropriate area, click Continue. Add your name. I like to keep the name similar to what I named it in the as a VM. So I'll type Ubuntu and enter a password. And I always leave mine set to require login, require password for login. Once the installation is complete, click Restart Now. It says, please remove the installation medium and then press Enter. You can just press Enter. It automatically does this for you. Log in using the credentials we entered. Get to a command prompt and check our networking. So we have an IP on our VirtualBox internal network of 192.168.1.11. And we should be able to get to our firewall. You'll get a warning about the connection not being secure. That's okay. It's a self-signed certificate. So we'll click on Advanced. We'll click on Add Exception. And we'll click on Confirm Security Exception. And we're there. This is the pfSense login screen where we can start configuring our firewall. Finally, we get to start configuring pfSense. Start up VirtualBox and make sure both your pfSense firewall and your Ubuntu desktop or whatever you're using for a GUI is started. Bring up your pfSense firewall virtual machine and make sure you know the address of the LAN interface. Mine here is 192.168.1.1. Yours will be too unless you changed that because it conflicts with your home network or business network. Then bring up your Ubuntu desktop and make sure that it's on the right subnet. Just do IP address and then grep inet. You can see we're here we're on the 192.168.1 subnet, so we're good. Then bring up your browser and go to 192.168.1.1. If you get a warning about their certificate, please click past that. That's just because we're using a self-signed certificate. Type in admin and pfSense for the password. And then click sign in. And we enter our initial setup screen. So we click on next. They're trying to get us to buy global support. If you're running a business, it may be worth it to get this support. I've never purchased it myself, but it kind of depends on how critical your infrastructure is. And it supports the project. And the price is reasonable, I think. Anyway, we'll click next here. Under general information, you can give it a different name or you can keep pfSense. For domain, you can have local domain. I'm going to type home.local domain. If you have an actual domain, you can put that in here. Primary DNS and secondary DNS. You can check with your internet service provider to put their IPs in here, their DNS servers IPs. Or you can use some global Google DNS servers. There's 8.8.8.8. and 8.8.8.4. And this is telling us that if our service provider gives us DNS servers, they can override what we've put in here, that's okay. So we'll click Next. You can leave the server host name, time server host name at its default, and change this to your time zone. I'm in GMT -5, so I put that in. Click Next. For the WAN interface, this is going to depend on how your network is configured. If you're on a home network, you'll likely leave this at DHCP. And you can leave the rest of these blank. And it's okay to block these private networks from coming in on your WAN interface and to block bogons. Bogons are non-routed IPs. Those shouldn't be used by anyone. So you can leave those checked. All the rest you can leave blank unless you have to configure it for your ISP. And then click Next. LAN IP, unless you need this to be on a different subnet, you could leave that at 192.168.1.1 with a 24-bit subnet mask. Click on Next. Now we're going to change our admin password. And click Next. And then we'll click on Reload and it will reboot our firewall. Hey, pfSense is now configured. I'm going to click on Check for Updates because I always update as soon as I can after installing a new system. And it says an update is available. So we're going to confirm and download the latest version. My internet connection is super slow, so I'm not going to make you wait for this. But once it's up to date, we'll start configuring some features. We've just done the initial setup on pfSense, but something still isn't working. So we'll have a look together. First, if you're using VirtualBox, please make sure your pfSense virtual machine and your Ubuntu desktop, if that's what you're using for your GUI, are running. I also have another VM running for some troubleshooting that's not behind the firewall. You could do this with your host system, or you could have another VM running. It's up to you. And looking at pfSense again, our LAN IP, just make sure you know that. If it's not 192.168.1.1, make sure you know what that is. And our Ubuntu desktop right now doesn't seem to be able to resolve names on the internet. That would be a DNS problem. So if we do ping www.google.com, this will just get me their closest Akamai server. It doesn't work. But if we bring up our other virtual machine and we ping www.google.com, it does work. And we get the IP address of the server where it was going to try and get to. So now if we try and ping by IP address, it works. So that means we aren't able to resolve the name. Our networking works, but our name resolution does not. So let's go back to our firewall. And let's see what might be holding us back here as far as DNS settings. I'm suspecting it's something with our DHCP settings. Yes, we have no DNS servers here. So for now, let's put 8.8.8.8 in here and 8.8.8.8.4. These are public DNS servers that Google lets anyone use. And let's give that a try. Okay, I did a reboot to make the DHCP settings take effect because restarting networking didn't seem to do it. And now it looks like we're getting out to the internet. Yes, we are. So what we had to do to make this start working was go into Services, DHCP Server, and add DNS servers here. Saved our changes and then had to do a release renew on the IP address on our clients to get the new settings. So we're good to go to start configuring our device. After you've done the initial setup and added DNS servers to your DHCP configuration, the next thing I recommend doing is enabling Secure Shell or SSH. Even if you don't have much or any Linux or BSD experience, I recommend enabling this so you can get to the FreeBSD command line on your pfSense firewall if you need to. Although virtually all management tasks can be completed via the web interface, and I encourage you to manage your firewall through it, some things are much easier done at the command line. One example is resetting your pfSense password. This will be covered in the Troubleshooting section. Enabling SSH is simple. Click on System, then Advanced, scroll down under Admin Access and look for the Secure Shell section. Check the box that says Enable Secure Shell. Leave SSHD key only, set to password or public key for now. This will let us use either the public key or a password. Configuring key-based authentication will be covered in the optional Enabling Public Key Authentication section toward the end of the course. Leave Allow Agent Forwarding unchecked and the port used at 22. These values can be changed if needed later, but we'll test with the defaults. Scroll to the bottom of the page and click Save to save your changes. That's it. Now that we've enabled SSH, we'll test to make sure it's working. I'll be testing from the Ubuntu desktop VM we installed for the lab. This is really easy. Just get to a command prompt and type SSH admin at 192.168.1.1. Of course, if the LAN interface of your firewall is different, you'll have to type that instead of 192.168.1.1. If things are working, you'll be asked to add the SHA-256 fingerprint to continue connecting. Type yes and hit enter. You'll be asked for your password. This is the password of the admin user on pfSense. If you type it correctly, you'll be taken to the pfSense menu screen. Detailed instructions on how to set up and use SSH clients for different operating systems is covered in the optional section on key-based authentication. In the next lesson, we'll add a user to pfSense. Lesson we're going to add a user. This user is just kind of an emergency fallback in case something happens to your admin user or you lose the password of your admin user. So from your pfSense dashboard, click on the hamburger or menu icon, choose System, then User Manager. Click on Add to add a new user. Enter a username and password. Enter a full name if you want. Expiration date, leave blank. Custom settings, we'll leave blank for now. We will add this user to the admins group by clicking on admins and then clicking move to member of. So you can see over here on the left, it would have groups that I'm not a member of. And on the right, it'll have groups that you want the person to be a member of. We only have admins at this point because we haven't started doing much with groups. If the person has an SSH key, you can add that here. We're going to cover that in the SSH lesson. And similar with the IPSec pre-shared key. So click on Save to save your work. And the new user is added. And the new user is a member of the admins group. In this lesson, you'll learn how to disable IP version 6. If you don't need IP version 6, consider disabling it. I very often only use IP version 4, so disabling IP version 6 saves me from having to duplicate all of my firewall rules or IP version 6 equivalents on my firewall. To block IP version 6 traffic globally on your firewall, disable IP version 6 traffic globally and on each interface. We'll also disable the default firewall rule permitting it on the LAN interface. To block it globally, go to System, Advanced, and click on the Networking tab. Make sure the Allow IPv6 checkbox is unchecked. Then scroll to the bottom and click Save. And it says here there's a note. This does not disable any IPv6 features on the firewall, it only blocks traffic. To disable IPv6 on your interfaces, we'll start with the WAN. Go to Interfaces, WAN. Under IPv6 configuration type, click None. Scroll down and save. And apply your changes. Before you can do this step for the LAN interfaces, you'll have to disable DHCP for IP version 6 on this interface. To do this, go to Services, DHCP for IP version 6, and uncheck Enable DHCP v6 server on this interface. Then scroll to the bottom and click Save. Then we go back to Interfaces LAN. And under IPv6, we select None. Then Save. And apply changes. And as a final step, go to Firewall, Rules, LAN, and disable the IP version 6 rule that allows all traffic. Just click the little Disable button and apply changes. And that's it. You've disabled IP version 6 on your firewall. In this lesson, we'll learn to customize the dashboard so you can set it up however you like. When you first log into pfSense, you'll have this dashboard. If there are any widgets you don't like, you can just delete them. I don't have Netgate service and support, so I don't need this window. So I'm going to delete it. I do like to see what's going on with my interfaces, and I like this system information screen as well. But let's add something else. Just click on the plus to see available widgets. I also like to see my firewall logs, so we'll add that. And now we have our firewall logs at the bottom. There are many widgets you can choose from. Some that might interest you are interface statistics, traffic graphs, OpenVPN or IPSec if you use VPN, Installed packages is interesting, but I don't generally want it on my dashboard. That's up to you. And that's about it as far as what I'd like to put on. But please have a look and customize it however you want. In this lesson, we'll see how to change the look and feel or theme of your pfSense firewall. I do like the look and feel of the pfSense web configurator. It's pretty clean and sharp looking and shows you what you need to see. It's also nice to be able to have a little variety though. To change your theme, go to System, General Setup, and scroll down to Web Configurator. You can see Theme is the first item under Web Configurator. Let's check out pfSense Dark. Click Save. And then go back to the main menu to see what it looks like. That seems pretty cool if you like dark themes. We'll try another one. There aren't very many, so we'll just try a couple here. Let's try Compact Red. It does give us a warning that this is a user-created theme, but it is packaged with pfSense. So that message could be an error. Go back to the main menu, and here's the Compact Red. I personally like the dark theme, so I'm going to stick with that. You can find sites that tell you how to rebrand pfSense yourself if you'd like. It's helpful to know some CSS, which stands for Cascading Style Sheets, if you want to do your own theme, or be willing to learn. Or you can find themes already created on the internet. However, bear in mind that this is a security device. Downloading and installing software developed by someone else could introduce security issues for you. So I generally stick with the provided themes. That's it for changing your theme. Prior to diving into firewall rules and configuration, we'll look at some considerations for best results in firewall deployment. We'll discuss rules and rule sets, stateful filtering, blocking versus rejecting traffic, and ingress versus egress. First, we'll discuss rules and rule sets. Firewalls process traffic and permit, take action on, or deny it based on rules. Once you create a rule, you assign it to an interface or to interfaces. Rules are read from top to bottom in the list, and traffic is processed based on the first match observed in the rule or rule sets. If you have a rule that is likely to be used often, it is best to have it higher in the list of rules. This will reduce the processing load on your system. The firewall won't have to go through a rule or rules that don't apply to get to the one that does as often if the common traffic is processed first. For example, if you use HTTPS a lot and SSH only a little, and you want to have rules to allow both, it makes sense to check for HTTPS first, then SSH. Now we'll discuss stateful filtering. You'll see this referred to as stateful packet inspection, or SPI, by some firewall vendors such as Cisco. You want your firewall to keep track of information going out, and you want it to let the return traffic back into the requester. However, you don't want to let unrequested traffic or potentially malicious traffic into your network. You don't want to have to define all this traffic manually because you likely don't know ahead of time what your users or even you will have to access in advance. The firewall keeps track of outbound requests and listens for and processes related replies in a state table. The state table records the source, destination, protocol, ports, and state of the connection, as well as the interface involved. You can see the state table on your pfSense firewall at any time by clicking on Diagnostics and choosing States from the menu. Some examples of state types are Established for active connections and FinWait2 for a connection that is or is expected to be closing. States are shown as pairs separated by a colon. Established : established means the connection is established from the perspective of the sender and the receiver as far as the firewall can tell. TCP is connection-oriented, so sessions can be established. UDP is connectionless, so state is kind of simulated or set up for the purpose of knowing what may be expected in association with UDP traffic being sent. You'll see states like single : multiple and multiple : single for UDP. Other protocols like Internet Control Message Protocol, or ICMP, will have states as well. Any outbound request that is expecting a reply must have an entry in the state table for the traffic to be allowed. Now we'll discuss blocking versus rejecting. Blocking traffic silently drops it, not notifying the sender in any way. Your device looks like it is turned off. Rejecting traffic sends an appropriate reply to the requester to let them know the device is there, but the connection is not allowed. In general, it is good practice to have internet-exposed devices block unwanted traffic, and internal devices reject traffic that is not allowed. Blocking theoretically makes it more difficult for an attacker to know your device is even there, and rejecting reduces the wait times associated with unanswered requests. Now we'll talk about ingress versus egress. Ingress and egress from the firewall's perspective, if it's a device between your home or business and the internet, refers to traffic into or out of your home or business network. If you want to go to google.com from a browser on your computer, the request from your computer to the nearest Google presence is considered egress traffic. It's going to leave your network and go to the internet. If you have a web server hosted in a DMZ off the opt port on your pfSense firewall, requests to that would be ingress traffic. Considering that the internet is a wild and crazy place with automated scanners and manual hackers constantly scouring any exposure for weaknesses, you'll typically want to disallow all ingress traffic with very rare, highly secure exceptions like virtual private networking or VPN connections. If your network isn't too complex, or maybe even if it is, you may want to consider egress filtering as well. You could start by allowing protocols you know you'll use all the time, like HTTP and HTTPS for web browsing, or SSH for remotely accessing servers you have on the internet if you have any, and making sure updates still work for all your computers and Internet of Things or IoT devices. Hopefully those IoT devices use HTTP and HTTPS, so they should not have any ports to open. You would also want to allow domain name system or DNS queries from all of your computers, or at least from your internal DNS forwarders or resolvers, so name resolution can occur. For your home network, egress filtering can be a great way to see what's going on. For work, you want to have a pretty firm grasp on what other protocols are needed for your employees to do their work before denying traffic. We'll cover some strategies for doing this with minimal chance of breaking things in an upcoming lesson. Try to mentally put yourself in the position of the firewall when deciding whether traffic is ingress or egress from its perspective. Traffic going into the LAN interface would be egress traffic from the network's perspective. Traffic going from the firewall out on the WAN interface would also be egress. Traffic coming into the WAN interface would be ingress. Traffic going out from the firewall toward the LAN on the LAN interface would also be ingress. I hope the following table will make this clearer. In this lesson, you learned about rules and rule sets, stateful filtering, blocking versus rejecting traffic, and ingress versus egress. In this lesson, we'll learn about whitelisting and blacklisting. They're just two different approaches to applying firewall rules. Blacklisting is denying things you don't want or things you believe likely to be malicious. Perhaps you want to block port 1337 because it's associated with Shady Shell. You create a rule to block it. It's great that you blocked one suspected bad thing on one port, but there are 65,534 more TCP port numbers. The bad guys will quickly migrate their badness to another port once people start blocking their first choice. Maintaining blacklists for suspicious ports is extremely difficult. This is not to be confused with SMTP blacklisting or DNS blacklisting. Although SMTP and DNS blacklisting is also difficult to maintain, there are enough people working at it to make it a worthwhile added layer of defense. Whitelisting is allowing what you do want and blocking everything else. You could allow HTTP, HTTPS, SSH, DNS, and NTP, for example, and block everything else. If you know what you want to allow, you don't have to know what you don't. Just whitelist what you want and block everything else. This is the default mode for ingress filtering. Consider putting it in place for egress filtering too. You can stop much badness that way. Just make sure you do some testing to make sure you're not going to break things, and we'll cover that in a later lesson. In this lesson, we'll talk about where to place firewall rules to provide the greatest protection to the resources you want to protect. And by placement, I mean where on the firewall, which interface. In the firewall graphic depicted, this is a very simple firewall configuration with a LAN and a WAN interface. Consider that you could possibly have many interfaces on your firewall, as well as many networks in the form of other physical or virtual network interfaces, or in the form of multiple virtual local area networks, or VLANs. If you want to keep TCP port 1337 from making it to the internet, if a computer is exploited on your LAN, it makes sense to block the rule on the LAN interface. Put the rule protecting the asset or others as close to the threat as possible. If you want to protect your LAN from traffic coming from the internet, you put the rule on the WAN interface. When you place your rules in this way, all the other areas of your network are protected by the firewall. You only specify an interface with pfSense, and pfSense automatically assumes the rule is on an inbound direction from the firewall's perspective. So if you apply a rule to the LAN interface, it will affect all traffic coming into the LAN interface toward the firewall. Likewise with the WAN. This makes adding rules much simpler than with other vendors' products. If you need more granular control, there's a special kind of rule called a floating rule that will let you control traffic in much more detail. And we'll cover that in a separate lesson. In this lesson, we'll have a cursory look at floating rules. To create a floating rule, go to Firewall Rules and click on the Floating tab. Then click Add. Some differences you'll see are that floating rules have a match option, which you won't find in regular rules. You can select multiple interfaces. You can select to apply quick, which is enabled by default, and you can't disable on a LAN or WAN rule. And a direction you can choose is any. You can also choose inbound or outbound. And inbound is chosen by default for you, and you cannot change that on an interface rule. Now we'll cover some high-level considerations for floating rules. There are some precautions with floating firewall rules. They are more flexible than regular rules, but because of that, they're also more risky. You could misconfigure something that may deny, or worse, permit traffic you don't intend. Also, they're more difficult to troubleshoot. Your fellow network administrators may not be aware of floating rules and may not look for them, causing extended troubleshooting. And even in and of themselves, they're more difficult to troubleshoot because of the many options available. Also, determining source and destination for packets is not always straightforward. Outbound rules applied to the WAN are applied after network address translation or NAT has occurred. So they have a local source of the firewall's IP. Some uses for floating rules include traffic shaping with Alt-Q, controlling traffic leaving the firewall itself, for example, to prevent the firewall from reaching specific IPs or ports, ensuring no traffic can exit from other paths into a secure network, regardless of any other firewall rules created elsewhere, and when you're using state timeouts, tag match operations, no state, and sloppy state rules for asymmetric routing. What is the processing order for floating rules? Rules for inbound traffic on floating rules work very similarly to interface rules. Firewall rules are processed after network address translation or NAT rules. So rules in the outbound direction cannot match a local source. You would have to specify the NATed IP address. And floating rules are processed before interface rules and group rules. When Quick is enabled for rules on your firewall, processing stops after the first match to a rule is hit. This is the normal default behavior for interface rules. On floating rules, you have the option of disabling Quick processing. With Quick disabled, the last matching rule that's hit wins. Quick cannot be used with tagged queuing when managed with floating rules. Unless you have a very good reason for disabling it, Quick should be kept enabled. With floating rules, you have the option to select any interface configured or multiple interfaces by holding down the Control key. You can also specify multiple directions. You could do any direction, inbound, or outbound. You can use the tag and tagged fields to mark and manage specific traffic. This can be used to take action on WAN outbound traffic from a specific internal host that would not have been matched due to NAT substituting the source address, for example. Then, time to roll up your sleeves. In this lesson, we get to configure a pfSense firewall rule. If you're using your VirtualBox lab, make sure your pfSense firewall is running, your Ubuntu desktop or whatever you want to use for your GUI. And it's helpful to have an external system running as well. In this case, I have an Ubuntu 18.04 server. Once you log into pfSense, go to Firewall, then Rules in the menu. We're going to block port 1337. You can see there's no rule for that there now. But first, we're going to do a quick test. On our external 18.04 server, we're going to use netcat to listen on port 1337. Then on our Ubuntu desktop, which is behind the firewall, we're going to telnet to our Ubuntu server outside the firewall on port 1337 just to see that this works. And if we look on the Ubuntu server, we just said hello. So we have communication going back and forth over port 1337. Now we're going to make a firewall rule to block port 1337 on the LAN interface. Remember, if we want to block something going out of the LAN, the best place to do that is on the LAN interface. So we'll go add. The action we'll want to take on this traffic is to reject. Remember, we can reject for internal IPs. We block for external IPs or external rules. Interface is LAN, IP version 4, transmission control protocol. We won't mess with advanced at this time. We'll look at that in a later lesson. If you want to specify just one port, you put it in the from side and you leave the to side blank. We definitely want to log packets that are handled by this rule. And we'll name this with a descriptive name, reject 1337 shady shell. And again, we won't look at advanced at this time. Then you click on save to save the rule. Then click on apply changes. Now we'll go to our server and start netcat. Then we'll go back to our VM and we'll try again. Oh, it's still working. What's going on? What do you think happened? Look at the server. And we're still communicating, even though we had a rule in there. What do you think is going on? Well, the problem is rule order. Remember, the first rule matched wins. So we have a rule here allowing traffic from any IP version 4 address on any port to any address on any port. So it hit this allow rule before it got to our deny rule. So what we want to do is move our rule up. Select the two rules you want to move this rule above. Hover over the anchor, it'll turn into an up arrow, and then shift and click to move this rule above those. Here we go. Now we'll click save again, apply changes, and we'll try it again. Start up netcat. And then try and telnet again to port 1337. And it says unable to connect to remote host, connection refused. So that's good. Then we'll go to related log entries. There's a fair bit of stuff in there. So we're going to look specifically for our port number. We'll click the little filter icon. We'll look for a destination port of 1337. And we see it was blocked. We see the source IP and the destination IP. So that's it. Now you know how to apply a firewall rule and move it up or down in your list so it works as you expect, and how to test and what to look for in the logs. We'll learn about firewall aliases. In the last lesson, we learned how to add a firewall rule. We could really only specify a few things about the rule, though. We could only, for example, put one port or one range of ports. What if we want to add several? You can add some flexibility and group things together with aliases. To add an alias, go to Firewall, Aliases. We're going to add some for ports, but you can add aliases for IP addresses, URLs, or for multiple things. We'll go with ports. So to add a new alias, you click Add. We'll name this put a description that makes sense. And we'll keep the type at ports, but you can see you could select from many things here: hosts, networks, URLs. And we'll put in some ports. We're going to try and define the standard ports that we're going to want to allow out. So we're going to allow port 80, HTTP, add a port 443, HTTPS, port 22, SSH, I use this to manage servers. If you don't need that, you don't have to add it. And port 53 DNS. We're going to have to add port 53 for a UDP alias as well. So we'll save this. And before we apply changes, we'll add another one for UDP. And we'll add port 53 for DNS. And port 123 for Network Time Protocol, NTP. Save. Apply changes. Applying changes just adds these. They aren't really doing anything yet until we apply them to an interface. So since we want to apply these to the LAN outbound, we'll go to Firewall, Rules, we click on LAN. So after we apply this rule, we will deny all traffic not allowed by the rule we just put in. So we'll click on Add. Action is going to be pass. Interface LAN, IP version 4. We'll do TCP first, and then we'll do UDP. And for destination port range, just put TCP standard outbound. Start typing in it. This should autofill for you. I'm not going to log these packets because it's going to be a lot of traffic. We'll put a description. Standard TCP standard outbound for LAN, save, and apply changes. And we'll add another rule. This time change the protocol to UDP. Start typing and UDP standard out should come up. We will log these. Put in a description, save, and apply changes. I'm not sure which of these will get more traffic. We'll just have a look after we've had it up for a while. And when we find one gets more traffic, we'll want that on top. We're going to add a rule to block anything that we haven't allowed above. It's going to actually reject. Protocol will be any. Source will be LAN net. And we do want to see what packets get dropped. And we'll save, apply changes. We'll move this rule up above the one that allows all traffic. Remember, hit Shift and that little up arrow. We'll save, apply changes. We'll disable the rule that allows all outbound traffic and apply changes. I just want to clean things up a little by moving this rule up one. There we go, save. We'll have one more look before we do some testing. So we've allowed UDP standard out, which is DNS and NTP. We've allowed TCP standard out, which is port 80, 443, 22, and 53. And we are dropping everything else and logging it. So fingers crossed, let's see if everything still works. Internet's working. NTP looks like it's working. And SSH is working. I'll try an update. Updates are working. Yes, looks like things are working. There's one more set of services we want to add, and that's some important ICMP messages. In this lesson, we'll learn to apply ICMP message types that are useful outbound to the LAN interface. ICMP stands for Internet Control Message Protocol. ICMP provides some much needed guidance in controlling traffic. ICMP messages are broken down by message types and codes. Some message types can be risky and should be avoided if not absolutely needed. Some, however, are crucial to the proper operation of your network. Here are the types I recommend allowing. Type 3, Destination Unreachable. Type 8, ICMP Echo Request, Ping. And bear in mind, you don't have to explicitly allow the reply back in. The firewall will keep track of that for you. Type 11, Time Exceeded. And Type 12, Parameter Problem. Please note that my recommendation here differs from the authors. They're saying allowing any type of ICMP is typically acceptable. While I defer to their knowledge regarding firewalls, as a security professional, I do know that some ICMP protocol types are abused. One example is source routing. If I would have to enable source routing to make my network work, I should just fix my network, not rely on a protocol to fix that for me. I will leave it up to you whether you want to allow all or whether you want to allow just the ones that I recommended. It's very easy to just select all instead of the individual ones that I'm recommending. Unlike with TCP and UDP, when creating a rule for ICMP, you can specify multiple types you want to work with in a single rule without the need for creating an alias. Go to Firewall, Rules, and click on LAN because we're configuring a LAN rule. Click on Add. It doesn't matter if you add to the top or the bottom of your rule list. We're going to move this to the right location when we're done. This will be a pass rule. It'll be on the LAN interface, IP version 4. Then we'll select ICMP for the type. You can see you get a whole drop-down list full of ICMP subtypes here. To select multiple types, you just click the Control key and left-click. We'll want Destination Unreachable, Time Exceeded. I'm sorry these aren't in alphabetical or type number order, so you just kind of have to scroll around and find them. Parameter Problem, and Echo Request. So we have those four selected. We will want to log these, and we'll put in a good description. Then click Save, Apply Changes, and we'll want it after the UDP and TCP rules. So put the check mark next to the one you want to move it below, and just click to move the ones checked above this one. And save, and apply changes. And we can make sure ping at least is working by just doing a ping and making sure we get a reply. So we've applied our new rule, and it appears to be working. You see we have Echo Request, Parameter Problem, Time Exceeded, and Destination Unreachable allowed. And it has to be above the Reject Any rule, of course, and it should probably be below the TCP and UDP rules we added earlier. These should be much less frequent than TCP and UDP traffic. And seeing that the vast majority of our traffic is TCP, this rule should be higher as well. So we'll go ahead and adjust that now. There we go. Now our most used rule is higher in the list. Save and apply changes. In this lesson, you'll learn some methods you can use to whitelist outbound traffic with minimal chance of denying something necessary for people to do their work. The ports and ICMP message types in the previous lessons will likely be all you'll need for your home network. On corporate networks, more protocols or ports may have to be allowed outbound than this. If you're the system or network administrator, hopefully you know any special needs that may have to be accommodated. If for some reason you don't, you'll learn how to figure this out in this lesson. You could have batch jobs that send traffic on non-standard ports or on ports that we may not have allowed. One way to look for this is to enable logging on a copy of the default outbound rule to permit all traffic. You can then look through the logs to see what was permitted. You can then weigh which ones you want to allow and block and test to make sure things are working. To do this, let's go to Firewall, Rules, and click on LAN. We have several rules here. We'll just ignore that and pretend we have a default configuration. We'll make a copy of the default rule that allows any outbound LAN connection. Click the little copy icon. We'll copy it just as is and then modify it. Click on Edit. We'll uncheck Disable this rule. That'll enable it. And we'll add a check to log packets that are handled by this rule. So click on Save, Apply Changes, and then we want this rule to be almost at the top. It's good practice to never put anything above your anti-lockout rule. If you have a mistake in your rule and it doesn't behave as expected and it blocks all traffic, and you put it above this anti-lockout rule, you'll lock yourself out of HTTP, HTTPS, and SSH access to your firewall. You'll be restricted to the console interface until you fix it. So we're going to move this rule so it's above all of these rules except the anti-lockout rule. You do Shift-click, and there we go. And the only difference between this and the default rule to allow any is that we're logging all traffic. Now bear in mind, if we have other rules here, none of those will get hit because everything will be met by this. So this isn't something you'd want to do long term. You just want to do this to see what's flowing. You aren't decreasing security from the default configuration. But if you've added rules that you want obeyed, those will be skipped. So then we can go to our log. Oops. If you get that message, it means you haven't saved a change yet. So make sure you click Save and Apply, and then do what you were going to do. So let's look at related log entries. There's nothing in there yet because we haven't done anything yet. So let's go to Google and see if we have anything in the logs. Yes. So we have some hits here. We have a hit for DNS and we have a hit for port 443. Looks like pretty much repetitions of DNS and 443. Oh, here's something else though. Oh, that's also 443. Okay, so far all we really see is DNS and internet traffic, HTTPS. What you could do when you're just configuring your firewall, if you want to see what's running, is leave this running for maybe a week if you have a fairly sophisticated infrastructure. And then you could do some filtering to see what ports you may be missing. So we can say exclamation mark 53. So now it'll just show us things that are not port 53 because we put an exclamation mark in front of it to use regular expressions. We can do the same with 443. Now we'll see things that aren't HTTPS. So you could use this strategy to figure out what protocols are flowing across your firewall. I'm going to get rid of this rule because I want my other rules to be used. So I just delete. Make sure you're on the right rule here when you do this. Before you're doing changes like this, it can be a good idea to back up your configuration. Backup and restore will be covered in a later lesson, but I can tell you unfortunately from experience that it's good to back up before doing changes like this. But just make sure you're on the right rule and click delete. Are you sure you want to delete this rule? Again, make sure and click OK. Apply changes. And the firewall is back the way it was. Another option is to go to Diagnostics, Packet Capture, and just capture packets on the interface you're interested in. Probably you're going to want to see what's going on your LAN interface. This, in my opinion, is kind of overkill. You're going to get a lot of data here. All you'd really like to see for this is what ports you may not already know about. You don't have to do a deep dive onto what's actually flowing. You can look up port numbers you don't recognize to see if you want to allow them or not. So I recommend the firewall rule way. If you want to dive a little deeper, you could certainly enable packet capture. In this lesson, you'll learn how to look at what your firewall is blocking with your new egress rules and how to tune them if needed. We'll have a look at my home SG1100 to do this. Chances are good that your firewall is blocking a fair bit of outbound traffic with your original rule set unless you followed the strategy for whitelisting outbound traffic lesson and created a whitelist based on your understanding of what you have going out. Even if you did some observation first, it's good to check the logs and see what may have been missed. Remember, our initial rules for the LAN outbound port are allowing HTTP, HTTPS, SSH, DNS on both UDP and TCP ports, network time protocol, and several ICMP message types. In reviewing my firewall logs, with those rules configured, I found two protocols we'll have a deeper look at. Both were blocked by my catch-all block any rule at the end of the list. One is Google's Quick protocol on UDP port 443, which I decided to leave blocked, and the other is Apple's push notification service on TCP port 5223, which I decided to allow. We'll start by going to Firewall Rules, and we want to look at the LAN. So you can see some rules here that I haven't gone through with you yet, like these DNS blacklist lists. We'll go over those in a future lesson. But here are the ports we just discussed that are allowed outbound. TCP, UDP, and several ICMP message types. Anything that gets past those will be blocked by this rule that catches everything that's left. So let's have a look at the related logs, and we're going to filter, and we'll look for anything blocked, UDP, port 443. Port 443 is usually HTTPS, so it caught my eye when I saw some log entries for UDP port 443. I wasn't aware of a protocol that regularly uses that port. So I looked real quick for for UDP port 443. And it says it's Quick UDP Internet Connections, QUIC. And it appears to be a Google project. You can see how much overhead is generated with a TCP HTTPS connection. You have several communications between the sender and receiver. And Google Quick, because it uses UDP, will be much lighter on your systems. It's supposed to be faster and use less bandwidth. However, it offers the disadvantage of bypassing my web filters. I don't have any web filters configured yet, but we will when we do our Squid proxy lessons. So I decided to leave that in block mode. The other rule I've added in our firewall rules, or the other port, was 5223, which is the Apple push notification service. It's worked its way out of my logs, so we really can't look at it there, but it looks similar to the log entry we just looked at. We'll go back to related logs again and see what else we can find. Let's look at this. UDP port 3478. And it looks like it's a stun port, or it could also be used by Apple. I'm going to go ahead and leave this as it is for now, but it's something we can keep an eye on. If any of my Apple devices are acting up, I can have a closer look at that. So that's how to tune your firewall rules to match what you're seeing in your logs. In this lesson, you'll learn how to put your rules in an order that will optimize performance and manipulate traffic in the way you intended. Although it has been hit upon in previous lessons, rule order on firewalls is so important, it deserves a quick lesson of its own. As already mentioned, the most used rules should appear first in the rule order. There are exceptions though. To view your rules, go to Firewall Rules. And we'll be primarily looking at the LAN interface. We see here that our default deny all rule has 52 kilobits of traffic, while our Xbox rules have far less traffic. We wouldn't want to move this rule above those though. If we do that, what would happen? That's right, these rules would never be hit. All the traffic would be denied and my Xbox wouldn't work. How sad. Similarly with UDP. Even if UDP were very low, we wouldn't want to move this rule above there, or DNS would stop working. If you haven't experienced DNS problems before, they really mess you up on anything to do with the internet. We'll cover the default deny or blacklist and default allow or whitelist considerations now. For default deny or blacklist, deny specific traffic you may want to stop. DNS blacklists, for example. Place your most used deny rules highest on that list. Place the next most used rules after that, and so on. Permit the traffic that you want to allow. Again, place your most used rules highest on the list. And then deny anything not permitted by previous rules. For a default allow or whitelist configuration, deny any specific traffic you may want to stop, such as a DNS blacklist. Place your most used deny rules highest on the list, and then the last rule should be one that permits any other traffic. And I've already mentioned it, but it's worth reiterating. Even if your default rules at the end, whether you use whitelisting or blacklisting, get more hits than other rules, you don't want to move those up. And if they do get a lot of hits, you probably want to see what's going on there. If you're doing whitelisting, this would be normal. If you're doing blacklisting and a lot of things are getting to your default deny list, you want to make sure you understand what those are. You may want to investigate if it's something that is sending traffic that it shouldn't and it's been infected, or you may want to allow something so you can have your needed services running on your network. As mentioned in a previous lesson, many of these rules, probably all of them, will have 0 if any hits on the WAN interface. This is because WAN traffic is allowed if it's being allowed in the state table. We aren't allowing any traffic by default from the WAN anyway, so any traffic that is allowed based on the state table entry. So someone requested traffic from the internet and the response is permitted. If you want to filter traffic here on the WAN interface, you'll have to configure a floating rule to catch those. So that's it for rule order. Remember, your default deny should be at the bottom of your list if you're using blacklisting, and your default allow should be at the bottom of your list if you're using whitelisting. And then order by your most used rules first, making sure that if you're using blacklisting, you deny specific traffic you want to deny first, and then permit things you want to allow. In this lesson, we'll see how to add rule separators so we can group related rules. To see what rules are configured, go to Firewall, Rules, and we're going to look at the LAN interface. We don't have very many rules configured, but you can see some are related. These were our standard outbound rules. So we have TCP, UDP, and ICMP that we want to allow outbound. We'll add a separator to describe those and give us a visual cue that they're related right now. Scroll down to the bottom and click Add Separator. Give a descriptive name for your separator. Choose a color. These are allow rules, so I click green, but you can pick whatever you like. Click Save. And then just click and drag the separator to where you want it. Let's add another one for our deny rule. And we'll click red because it's a deny rule. Save. And put it up here. So now we can easily see we've got a bunch of standard outbound rules and we've got our deny rule. We could have specialized cases where we want to allow some more ports. One example for me on my home firewall is Xbox. Xbox needs a bunch of ports open, but they aren't my standard ports, so I didn't want to add them here. I just put some more ports in for my Xbox and put a separator. After you're done, click Save and Apply Changes. And you're done. That's it for adding. This lesson is an introduction to the pfBlockerNG installable package for pfSense. pfBlockerNG is an extremely useful plugin. I recommend everyone with a pfSense firewall install it. Dallas Hasselhorst, on his blog Linux Included, said that if he could choose only one package to enable on pfSense, pfBlockerNG would be it. Dallas has several outstanding blog posts about pfBlockerNG, among other things. A link to his blog is provided below. I agree with Dallas. The suite of tools provided with this package is indispensable. Per the pfBlockerNG info page on the Netgate documentation, pfBlockerNG allows assigning many IP address URL lists from sites like iBlockList to a single alias and then choosing a rule action, blocking countries and IP ranges, replacement of both country block and IP block list by providing the same functionality and more in one package, and it uses native functions of pfSense instead of file hacks and table manipulation. Features include country block features, IP block list features, XML RPC synchronization, dashboard widgets with aliases applied and package hits. Lists are updated frequently. Many new options to choose what to block and how to block. And network lists may be used for custom rules. pfBlockerNG aggregates several IP and DNS block lists into a single list that can be checked by your firewall. These lists are drawn from popular feeds. Stopping traffic before DNS name resolution is even complete can save a lot of effort by your firewall and a lot of risk for you. If resolution of a bad site completed, the firewall would then have to analyze all traffic using other tools, hopefully recognizing and stopping the bad traffic. You're stopping name resolution from occurring, so malware that relies on it can't phone home to receive further instructions or malware. In the following lessons, we'll install and configure the main features available with pfBlockerNG. If you like the project, please consider contributing to bbcan177's Patreon campaign. I did. He's put a huge amount of effort into making this a useful, easy to install and use package. You could just Google for bbcan177 Patreon. We'll install a pfBlockerNG package in this lesson. Installing pfSense packages is pretty straightforward. Go to System, Package Manager, and click on Available Packages. There are a lot of packages you can choose from. They're in alphabetical order, so scroll down to pfBlockerNG. You can see there are two entries there. There's pfBlockerNG and pfBlockerNG Developer, which is -devel. I would normally not install a developer package on a production system, but I'm going to go with Dallas Hasselhorst on this and with my own experience and say that this is a stable package and there are features that I want you to be able to use available on the developer release. So click Install and confirm. You'll see progress as it installs. And I recommend not clicking away from here until it's done. And it says it's done and it was successful. Now if we go back to installed packages, we see that pfBlocker is installed. We can also see that it's now available under Firewall, pfBlockerNG. So that's it. You've installed pfBlockerNG. In upcoming lessons, we'll learn how to configure it. Good job. In this lesson, we'll enable pfBlockerNG and configure DNS blacklisting or DNSBL and IP blacklisting using a setup wizard. We can see that nothing for pfBlockerNG is enabled even though it's installed because we haven't enabled anything yet. To use the wizard, go to Firewall, pfBlockerNG, and it brings us to a wizard that will configure an entry-level configuration for IP and DNS blacklisting. We'll look at how to manually configure these in a future lesson. So to continue in the wizard, we'll click Next. And it's saying that any settings we had before will be wiped out. And it will configure a kind of standard or default installation for IP blacklisting and DNS blacklisting. It'll block the worst known malicious domains. So we'll click Next. The inbound firewall interface is the WAN. The outbound interface is the LAN. So we click Next. It configures a virtual IP address to send blocked traffic to. We'll just leave the IP address and the port numbers at default and click Next. It gives us one more warning that everything's about to be wiped if we have any configuration. This is a brand new installation, so we don't have anything. So we'll click Finish. And it's running its first update. It says pfBlockerNG has been successfully configured and updated. It will now block IPs based on some recommended feed source providers. It'll also block most adverts based on feed sources including EasyList, and Easy Privacy. It says to review the update log for any errors, so we'll scroll back up and make sure there weren't any errors. It does tell us we've hit a hard limit of 400,000 table entries. That should be plenty. Then we'll just scroll back up real quick and look for any other errors or messages. The wizard set quite a few things up for us, and we see no other errors except for the 400,000 entry limit reached. If you have VLANs, it says you should enable DNS blacklist to permit firewall rule options to allow all subnets to access the blacklist. We don't have any VLANs configured at this time. And we can look at things that are reported under the Reports Alerts tab. If we see anything there that we want to allow, you can whitelist it right from the Alerts tab. And then we can look in Reports and Statistics tabs for an in-depth summary of all IP and DNS blacklist events. So let's take a look at the IP tab. It says it's enabled. These defaults should be fine for us. And DNS blacklist. It says that's enabled. TLD is not enabled. And we'll cover that in a different lesson. The wizard quickly and easily set up IP and DNS blacklisting for us, with very few things to do on our part. That's it for this lesson. Good job. So what is an intrusion detection system, intrusion prevention system, or IDS, IPS? As the name implies, it's a system for detecting and/or preventing network intrusions. When attackers try to find and exploit vulnerabilities on your servers, there are patterns in the network traffic that can be detected and, if configured for prevention, blocked upon detection. One simple example is a directory traversal attack. When an attacker tries to find a vulnerable server, there will be attempts to go up directory levels sent in her requests to your server. The GET request to your web server will look something like this. In simple terms, the IDS can look for a pattern like ... and create an alert if it's seen. That's not something you would normally type, but it is something a manual attack or an automated tool would put in to try and detect directory traversal vulnerabilities. It could also block the offending IP address if it's configured for prevention. This will keep the attacker from going after your server for a length of time you determine, or permanently until you manually allow the traffic from there again. An IDS or IPS can have hundreds or thousands of patterns like the above that check traffic for many, many types of attacks. This is an example of signature-based detection. Snort does signature-based and protocol-based detection. Signature-based detection is described above. Stateful protocol analysis looks for deviations in a predefined set of norms for how a protocol should function. If someone is using Secure Shell or SSH over a port other than its standard port of TCP port 22, Snort should detect this and respond accordingly. We'll be installing Snort IDS IPS on pfSense and looking at its operation in some upcoming lessons. Installing Snort on pfSense is pretty straightforward. Once you log into your firewall, go to System, Package Manager, click on Available Packages, and you can see it's a pretty huge list. We're going to scroll down to Snort. Right here, the latest is Snort 3.2.9.9_1. Snort is an open source intrusion prevention, intrusion detection system. And click on Install. Click on Confirm. And leave this until it goes through all these steps. So it's on 2 of 9, 3 of 9. Just let it go until it gets all these steps done. And it's installing and doing a base configuration of Snort for you. You can look through the installation notes if you'd like. What we really want to see is this success message at the end. It also says Snort installation successfully completed at the top. Now we go back to installed packages and it says Snort is installed. In the next lesson, we'll do some initial configuration. As mentioned in a previous lesson, Snort runs on rules. Before we dive into configuring Snort, it's helpful to understand rule sets and to be prepared to download and install them by registering with Snort for rules you want if that's applicable for the rules you want. Rule sets available for download are Snort VRT, Snort GPL version 2, ET Open and ET Pro. ET stands for Emerging Threats. And Open App ID detectors. I'll discuss each of those now. Snort VRT. VRT stands for Vulnerability Research Team. It used to be a group of volunteers on the Snort team, but I believe it now falls under Talos, which is still a team at Snort, but I believe is paid. From the Snort Talos site it says, Talos, formerly the VRT, is a group of leading-edge network security experts working around the clock to proactively discover, assess, and respond to the latest trends in hacking activities, intrusion attempts, malware, and vulnerabilities. There's a free subscription and a paid subscription. The free subscription is 30 days behind the paid subscription service, so you won't have updates until 30 days after they're discovered by the VRT team. You'll still have a huge database of rules, historic rules that cover many things, and existing threats, but you won't have the very latest. The paid subscriber rule set is full-featured and is updated twice a week or more often if a vulnerability comes out between updates. I recommend a paid subscription for business, and if $29 a year sounds reasonable to you, a paid subscription for home too. A business license is a bit more pricey at $399 per sensor, but considering what you'd spend on a product like a Palo Alto subscription or anti-malware for your company, it seems very reasonable. Snort GPL version 2 rule set. The Snort GPL version 2 rule set is the official community rule set. It's certified by Talos, and on the pfSense configuration page it says it's free of charge without any Snort subscriber license restrictions. It's updated daily but only has a subset of the subscriber rule set. ET stands for Emerging Threats. The ET rule sets are maintained by Proofpoint. The free version of Emerging Threats, the open source one, offers more limited coverage than the ET Pro version. ET Pro has daily updates and extensive coverage of current malware threats. The site seems to direct me to a sales rep instead of telling me the price, so I doubt it's very cheap. I'll post the price if I find one, but I recommend ET Open unless you feel the need to research how much ET Pro costs. SourceFire OpenAppID detectors. OpenAppID is an application-focused detection language and processing module for Snort, according to the Snort website. OpenAppID is free, and I recommend enabling this rule set. In upcoming lessons, you'll learn how to enable rule sets you choose and how to schedule automatic updates for them. Enabling rule sets is pretty straightforward. If you haven't already done so and want Snort VRT rules, please register with Snort. You just go to snort.org and click Sign In. And if you don't already have a registration, just create one. It's free. And the easiest way to register for your free rule set is to go to Services, Snort, Global Settings, and click the link to sign up for a free registered user rules account. If you'd like the personal edition, it's only $29.99 per year, $30 a year. Business is $400 a year, $399 a year. And I've already signed up, so I have my free OINC code already. Personal seems really reasonable at $30 a year, so I will be doing that for my home router, but I'm not gonna do that right at this time. So once you do this, you'll get your OINC code, and you can copy this, and you'll be using that as you register. So we'll click Enable Snort VRT. It's asking for our code. We come here and copy the code and paste it. Since we're doing the free version at this time, we'll enable Snort GPL version 2. We'll also enable Emerging Threat Open. I don't have a Pro license, so we'll leave that unchecked. We'll enable OpenAppID, and we'll enable rules for OpenAppID. I update once a day, and I do it at a time where I probably won't be on the computer or on the network because I have a horrible network at home, horrible internet service provider that oversubscribes, so I don't have very good bandwidth. I do like to hide deprecated rules. Deprecated rules are rules that are no longer supported, so they shouldn't really be used. And if you check this, you won't see those, so you won't be able to use them. You don't need to disable SSL peer verification unless you're on a corporate network and you're using a web proxy and you're using a trusted certificate at work. So you should probably be able to leave this unchecked for home. You may or may not have to check this at work. Please try without this checked and see if that works for you, and then revisit it if you have to. For remove blocked hosts, you can leave it at never, or you can select an interval. I'm going to put 4 days since this is at home. You may think you want never, but there's 2 reasons you may not want to do that. One is if you're working on a corporate device and it's remote and you don't have physical access and you lock yourself out for some reason, you will not be able to get back in until you get access to your firewall through different means. And the other is that IP addresses change ownership all the time. A bad guy could be operating on an IP address one day and a good guy the next. And you won't be able to get to the website of the good guy if you block it forever. I leave remove blocked hosts after deinstall unchecked, but please check this if you're uninstalling and reinstalling for troubleshooting purposes. If something's not working right in Snort and you want to uninstall and reinstall, please consider checking that. Also, keep Snort settings after deinstall. I leave this checked, but if I'm removing for troubleshooting and reinstalling, I want a clean install, so I would uncheck that. And I do check startup shutdown logging, so I'll capture detailed system logs about startup and shutdown events. And then click on Save. In the next lesson, we'll do updates, and then we will assign Snort to interfaces in a future lesson. Before you can start using your new Snort IDS IPS, you'll have to do your first update. Although it's really easy to kick it off, it can take some time depending on the speed of your internet connection. Just go to Services, Snort, click on Updates, and then click on Update Rules. You'll get this pop-up that says updating rule sets may take a while. Please wait for the process to complete. This dialog will auto-close when the update is finished. I'm going to leave that up until it's finished. You can see that once the signatures are updated, you'll get a result success. You'll see MD5 hash signatures for each rule set, and you'll see a date that the MD5 signature was generated. So we know Snort is up to date. Next, we'll assign Snort to interfaces. This lesson we'll talk about choosing a deployment strategy for your IDS or IPS. We'll discuss enabling rules on interfaces soon, but before doing that, it is useful to discuss the detection versus prevention piece of an IDS IPS. In detect mode, an IDS will tell you badness is occurring, but will not act on that information other than generating an alert and log entries that something potentially dangerous is happening or has happened. In prevent mode, an IPS will actively block offending traffic. For Snort, that means once a Snort rule has been violated, Snort will block the traffic from the source or the destination or both IPs as you specify. In Snort, on pfSense, enabling prevent mode is done by checking the block offenders and optionally kill states checkboxes in Services, Snort, Edit Interfaces, LAN or WAN or Other, and then LAN Settings and Alert Settings. We'll look at that now. So you go to Services, Snort. I'm going to pick LAN. Just edit. And under alert settings, it would be block offenders. If you check this, it's in prevention mode. It's going to stop that traffic. Kill states will stop existing sessions. Let's say you went to a server and everything was fine, but then some badness was detected. Something on that server tried to attack your network, and that's recognized by Snort. Snort could then drop that active session, even though it was originally okay. And then which IPs to block? Do you want to block the source, the destination, or both? If you're pretty familiar with firewalls and your network, using prevent mode may be fine from the start, provided you're prepared to do some quick troubleshooting if something is blocked from a false positive. When I was managing a network with a lot of developers, something in the way they did SSH tunneling was triggering false positives and blocking their traffic. I don't remember the details now, but I was able to pretty quickly find the rule that was causing the false positives and tune it or disable it. It happened as soon as I enabled Snort IPS in front of the servers in my environment, so it was easy to know that it was firewall related and to fix it. If you're new to such activities, or you're not sure whether you may have some false positives that could block your network traffic, you may want to start with block offenders unchecked. leaving Snort in detect mode. You can check the logs to see what's been alerted on, tune it, and then enable for blocking once you're sure you won't be blocking legitimate traffic. For a corporate network, or for someone who has never administered a firewall, whether home or business, I recommend getting familiar with the firewall by using monitor mode for a few days or weeks before enabling prevention by checking block offenders. Also remember, if you're putting pfSense outside your home wireless device, you'll likely be using network address translation from that device to pfSense. That means everything on your home network will look as though it's coming from the one IP address for the outside interface on your home wireless access point firewall router. If anything on your home network is flagged by Snort, your whole home network will not be able to reach the internet until you troubleshoot the problem. This issue would mainly come to light if you enable block offenders on the LAN interface blocking the source IP address. To summarize, if you're feeling lucky, you may go straight to blocking mode, but I recommend the more cautious detection mode until you see what Snort alerts on. Okay, you've selected your rule sets and updated them. There's one more step before Snort will start doing its thing and protecting your network. You have to assign Snort to interfaces on your firewall. I recommend enabling Snort on both the inside and the outside interfaces. Bear in mind, if you're placing pfSense outside your home wireless router or firewall, or outside another router or firewall at work, all the traffic on the inside interface of pfSense will appear to be coming through your NATed IP address of your device. That means if there's one offender on your inside interface, all traffic to pfSense may be blocked until you fix the problem and find a different way into your firewall. I'm okay with this risk on my home network. If you're paranoid and you have management support on your corporate network, you can configure it at work as well. An alternative is to configure your internal interface in IDS or detect mode and your external interface in protection mode. Then watch your logs for alerts. If you're alerted, but don't see it for days, weeks, or months, it'll be very late in the game for you to try and repair the damage. To assign rules to interfaces, go to Services, Snort, and Snort Interfaces will already be selected. Click on Add. We'll do the WAN interface first. Leave Enable Interfaces checked. Interface is WAN, description is WAN. We don't worry about the snap length. I do like to send alerts to system logs. We'll leave these at default. And on the external interface, I do like to automatically block hosts that generate Snort alerts. We'll block the source IP. We'll leave these all at default, unchecked. We'll also leave the networks Snort should inspect and whitelist at defaults. And we don't have a suppression or filtering list at this point, so we'll leave that default. And we have no advanced configuration pass-through options configured. So you click Save. We'll add our internal interface as well. Send alerts to system logs, block offenders. We'll do source again. Leave defaults. And remember, with block offenders, if you're at work, you may want to not do this and just very carefully watch your logs every day. Click on Save. Then we're going to start Snort on the interfaces. And we're successful. You've got Snort set up in a basic configuration. Good job. Welcome back. In this section, we'll install Suricata intrusion detection and intrusion prevention system. Suricata is a kind of meerkat. Perhaps the name was chosen because meerkats are watchful creatures always on alert for danger. Snort is older and has a large community for support and documentation. Suricata is newer and supports multi-threading, which can greatly improve performance. Suricata also supports IP reputation and automated protocol detection. I see those as the key differences, and beyond that, I leave it to your personal preference which you choose. You can try both and see which you like best. I don't know if it's possible to run both Suricata and Snort on the same firewall at the same time, but even if it is, I don't recommend it. Having two services trying to manage network flows at the same time will be resource intensive and may result in conflicts and difficulty in troubleshooting. In this section, we'll remove Snort, install Suricata, configure Suricata, and test IDS functionality. Let's get started. Welcome back. In this lesson, we'll remove Snort in preparation for installing Suricata. Let's take a moment to do a quick backup before removing Snort so we can quickly go back if you decide you prefer Snort. Go to Diagnostics, Backup and Restore, and be sure that Skip Packages is not checked. If this is checked, it will not back up packages, which is not what we want. So make sure this is unchecked. You can encrypt if you like. You'd have to put a password in here, and don't forget that password or you won't be able to get into your file. And then click Download Configuration as XML. Click Save File, OK. And then it'll typically go into your Downloads folder. To remove Snort, we'll go to System, Package Manager. You click the trash can icon next to Snort. Click Confirm. And your system will remove Snort for you. And it says pfSense package Snort removal successfully completed. If we click back on installed packages, there will be none now because we removed the only one we had on this firewall. In the next lesson, we'll install Suricata. Good job. Welcome back. In this lesson, we'll install the Suricata package. Click on System and Package Manager. Available packages. Scroll all the way down to Suricata and click Install. Click Confirm. And let the package manager download it. And we get the message, pfSense package Suricata installation successfully completed. And we look at installed packages. And Suricata is there. That's it. In the next lesson, we'll start configuring Suricata. Good job. Welcome back. In this lesson, we'll configure Suricata's global settings. Click on Services, Suricata, and Global Settings. Check the box to install ET-Open Emerging Threat Rules. Of course, if you have a Pro license, you can install that. I do find Emerging Threats license subscriptions kind of pricey, but if you're interested, you could contact Proofpoint if you'd like to explore your options. if you have your Oink Master code, I still love that name, you can install Snort rules. And you can install Snort GPL version 2 community rules, and this doesn't require any license or registration. If you have a paid Snort license, you will get these rules as part of your download. I do have a paid subscription for about $30 US per year for my home firewall. And even corporate subscription is very reasonable if you want to explore those. I don't worry about hiding deprecated rules, I just leave those. For update interval, I select once a day, and I set my time for 2 in the morning. You can set that to whatever time makes sense for your network, whether it's your home network or your business. You'll probably want it to be off hours so you don't affect bandwidth. And if you have multiple firewalls, remember not to have them all update at the same time, or you could run into performance issues on your network. We're going to check live swap on update, but I'll update the lesson if this causes a problem for me. I don't know, it says it could cause problems, but let's give it a shot. And for the GeoLite 2 update, we're going to get these, but we'll have to get a license key from MaxMind. So we'll click on Register for a free MaxMind user account. You'll receive an email on how to set up your MaxMind account. Go to Services and click on My License Key, and click on Generate New License Key. This key will be used for GeoIP update. As instructed here, it says use GeoIP update version 3.1.1 or newer. Then we confirm. And here's our license key. We could have just clicked copy. We'll paste that here. And for remove blocked hosts, I recommend 1 hour. But please use your own judgment there. If you manage a remote site and you have to get into pfSense, and there's a chance you could lock yourself out, 1 hour is a long time not to be able to help with an issue there. So you may want to set it to lower than that. You could set it to 30 minutes or 15 minutes if you want to. And if it's for home, you could set it longer, or even set it to never. So a blocked user would never be allowed in until you manually remove them. Now bear in mind that malicious activity shifts around quite a bit. So bad guys will use sites like DigitalOcean or things like that. And once they're done doing their badness or they get caught and booted off, that IP could be reissued to a legitimate user, and they then would be blocked. So you probably don't want to keep it on never, but just do what you think is best there and adjust it as you need to. We will not log to the system log, but if you use syslog and you send all your messages to a syslog server, you may want to check this. And we will leave this checked to keep all settings, Suricata settings after deinstall, but you would probably want to uncheck that if you're going to remove Suricata and leave it off. This is just if you're taking it off and reinstalling it for some reason. So we click Save. And that's it. In the next lesson, we'll click on Updates and we'll look at how to update for the first time. Welcome back. In this lesson, we'll do our first updates for Suricata. So you go to Services, Suricata Updates. And because nothing is ever updated, of course everything says unknown. It would update at 2 in the morning if we wanted to wait. But let's check and make sure that our updates will work. So we don't have to wait until tomorrow to find out there may be a problem. So you click Update. And it says updating rule sets. This may take a while, and we'll just make sure you could close this, or you can just leave it and let it close by itself when the update is done. But we're going to let this go, and we're going to check back on it in a few minutes. What you'll see when this downloads successfully is the MD5 hashes and the MD5 signature update times. I don't have Snort configured yet, at least with the Snort subscriber rules, but I will, and I recommend you enable that. In the next lesson, we'll assign interfaces to Suricata. Good job. Welcome back. In this lesson, we'll assign interfaces to Suricata so we can monitor them or block malicious activity on them. To add an interface, go to Services, Suricata, Interfaces, and click on Add. We'll start with the basic WAN settings. Be sure Enable is checked. Interface should be WAN. Description, I just leave it at WAN, but you could make it more descriptive if you'd want. I leave Send Alerts to System Log unchecked. If you have a syslog system that collects and manages logs for you, you may want to check that. I also leave Enable Stats Log unchecked. Enable HTTP log, append, HTTP log, and log extended HTTP info are all checked. Enable TLS log and tracked file log and enable file store along with enable packet log are all unchecked. You could check these as you'd like. You can test them out, see if you get useful information and if there's a useful balance between what's logged and log space. I think the most chatty of these would be enable packet log. I leave Eve JSON log off. Eve is extensible event format, and it puts all alerts, HTTP logs, anomalies, and metadata into a single file that is formatted so it can be read by third-party tools like Logstash or JQ. More info is available in the downloadable PDF with the link or in the description for the lesson. Looks like an interesting thing to explore, but we'll leave it for now. Block offenders. Make sure this is checked for your WAN and leave your IPS mode at legacy mode. This way we don't have to worry about whether our NIC driver works with NetMap. Kill states. This means that if a connection is up and malicious activity is seen later and one of the IPs is blocked, this will stop that traffic along with any future traffic. Under which IP to block? For WAN, I select source. This will mean an IP on the internet that's coming into our network would get blocked. Leave block on drop only unchecked. If you do check this, it would only block on drop actions. If you don't check this, it would block on alert or drops. So we'll leave that unchecked. Run mode, we'll leave an auto FP. Max pending packets, we'll leave at 1024. Detect engine profile, we'll leave at medium. Pattern matcher, algorithm auto. Signature group header auto. Inspection recursion limit we'll leave at 3000. Delayed detect we'll leave unchecked. Promiscuous mode we'll leave checked. And interface PCAP snap length we'll leave at 1518. All the HomeNet, ExtraNet, and pass list we'll leave at default. Alert suppression and filtering we'll leave at default. And advanced configuration pass-through is left blank. Then we'll click on Save. We'll look at WAN categories. We'll enable the Snort GPL version 2 rules. And then for WAN, we'll try Select All. For LAN, I do not recommend this at first. You want to look kind of carefully through the rules and try and pick ones that make sense for you. Then we'll click on Save. And then we'll start Suricata. I recommend the same settings for the LAN, except that at first I recommend not checking block offenders. Just look at logs to see what kind of traffic you may have and to tune. LAN categories. I would keep this less restrictive depending on your company's policies if you're at work. And if you're at home, just make it reasonable. You can definitely enable these, the Talos certified rules. And if you see any here that make sense to you, you can enable them and see how it works. And go back to interfaces. Enable Suricata for LAN. And you won't have this yet until you do the next section, but there's a DMZ set up here. And when you have your DMZ set up, I would block in both directions. You should have very little traffic that's not standard going into or out of your DMZ. And again, categories for the DMZ, you can be quite restrictive here. And save. And back to interfaces. And start. It's tough to see if blocking is working without some allowed ports. That's why I'm testing on this DMZ setup. And you'll learn how to set up a DMZ, as I said, in an upcoming section. But for now, we'll just see that Suricata is working and is blocking. Welcome back. In this lesson, we'll make sure Suricata blocks malicious traffic. You won't be able to follow this lesson as I present it until you get a DMZ set up. If you run any scanning tool against a WAN interface with no ports open, you won't see anything at all and your packets will be dropped, which is a basic purpose of a firewall. To see interesting traffic, you'll want to allow at least one port through. You'll learn how to set up a DMZ in a future section. For us, we're going to have an Nginx web server listening on port 80 in our DMZ. You'll learn how to set up a DMZ, an Nginx server, and how to test that it's working and blocking malicious traffic with Snort in an upcoming section of this course. For now, I want you to see that Suricata works as we've configured it. I'll be running Nikto from a Kali Linux virtual machine I have running. Kali is free to download and is designed specifically for penetration testing and network forensics, so it has a lot of tools built in. I'll be using a free, easy-to-run, quick and dirty web scanner called Nikto. You can download Nikto for free, and it's available for Linux, Windows, and Mac OS. We'll start with Suricata disabled on the WAN and DMZ interfaces. So go to Services, Suricata, and click the Stop button on the WAN and DMZ interfaces. Find the public IP of your pfSense firewall. You can find that by just clicking on the pfSense icon in the upper left and looking at the WAN interface. So you can see ours is 192.168.254.102. We'll make sure that we can see the Nginx default page on that site and refresh to make sure it's not cached. And at the terminal, we just type nikto --host and then the IP address. And it'll take maybe 30 or 40 seconds to run. And then once you're done, you can see how long it took to run and what it found. So let's try again with Suricata enabled on those interfaces. We'll click Start. It's probably good not to start two interfaces at once. And we'll try our scan again. And this time, you really can't see it yet, but it's already timing out. It's not working. So let's look at blocks. And you can see that it saw a Nikto web scan is in progress, and it blocked our IP. I'm going to stop the scan. And that's our IP, and it blocked it. It saw the Nikto scan was coming in and stopped it. So if this is not malicious traffic, this is malicious traffic because it says Nikto. You know somebody was running a web scan. But if it's a false positive of some kind, you can tune your firewall by seeing what rule was used or rules and setting it not to block on those rules. But if you just want to get someone off your block list, you can click Remove. And now, if we go back to our web page and we refresh, you can see that the default Nginx page is still coming up for us. That's it for this lesson and this section. You've enabled Suricata, added rule sets, added interfaces, and tested to make sure it blocks malicious traffic. Welcome back. In this section, we'll configure a demilitarized zone, or DMZ, for an Nginx web server. We'll also configure Snort to protect our server. Here's what we'll cover in this section. You'll understand what a DMZ is and why it's useful. We'll review the network topology of our lab environment. We'll configure networking for our pfSense firewall to accommodate our DMZ. We'll do this by adding a physical interface, and we'll configure the new opt interface to be our DMZ interface. We'll also spin up a Linux Mint VM for the internal network and a Linux Mint VM for our DMZ network. Then we'll configure the firewall to permit traffic from the DMZ for testing. Then we'll add firewall rules to send web traffic from the outside interface to the DMZ. and we'll configure firewall rules to allow SSH to our web server from the internal network so you can manage your server. We'll also protect our web server with Snort. Lots of fun stuff ahead, so I'll see you in the next lesson. Welcome back. As mentioned in the last lesson, DMZ stands for Demilitarized Zone. It's a term borrowed from the military. Think of the boundary between North and South Korea. This is perhaps the most famous DMZ. The fenced-off and heavily guarded and patrolled border is a no man's land. Anyone in there is suspect. Anyone having to enter must be authorized, and they will be very closely monitored by both sides. It would be very nice if we could trust people to behave well when we expose a server to the internet, like a web server or an email server. As you'll see from your logs on any server exposed to the internet, this just isn't the case. Hostile forces are constantly looking for weaknesses in our servers, and if they find any, they'll try to exploit them and take over or abuse our server. The next logical step for an attacker is to see what else she could get into after breaking into the exposed server. If someone breaks into your web server and your web server is on your internal network, the attacker would be able to go after any system on your corporate local area network or LAN. If you configure your environment as I recommend and show you here, damage from such an attack will be limited. You should put any service you have to expose to the internet or to people outside your network in a DMZ. Anything in your DMZ should be hardened and monitored closely for any sign of compromise. Network traffic to and from the server should be tightly restricted. For a web server, only web traffic from the internet should be allowed to access it. Management traffic, such as SSH for Linux or Remote Desktop Protocol or RDP for Windows, should only be allowed from the internal network. The DMZ server should not be allowed to communicate with the LAN except in very controlled circumstances, like allowing logs to be sent to a log server. To summarize, a DMZ is a network location where you can put things you want to share with outside consumers. Traffic flow into and out of the DMZ should be closely monitored. See you in the next lesson. Welcome back. In this lesson, we'll have a look at the network topology of our DMZ. We'll be setting this up in VirtualBox. The topology is pretty straightforward. We'll allow incoming traffic from the internet, in this case our home network, or the place we're hosting VirtualBox, into our web server in the DMZ over ports 80, HTTP, and 443 for HTTPS. We'll deny all other inbound traffic from the internet. We'll allow traffic from our internal network over port 22, which is SSH, so we could manage our server from the corporate network. We'll add a network interface card on our pfSense firewall, which will become our DMZ. This interface will use a new internal-only network called INET2. For my VirtualBox environment, I use 192.168.254 network for the WAN, the 10.0.0.0 network for the DMZ, and the 192.168.1.0 network for the internal or corporate network. These are all Class C or /24-bit masks, and the mask would be 255.255.255.0 if you spelled it out. We'll go through the steps for the entire process in upcoming lessons. Welcome back. In this lesson, we're going to get pfSense set up to use our DMZ. There are a few things to look at in settings. All of them are on the network. First, make sure that your adapter 1, or your WAN, is set to bridged adapter. It could be a challenge to get it to work if you have NAT or network address translation selected. So make sure it says bridged adapter. Adapter 2 should be attached to an internal network, It's called intnet. I think I said inet in the other video. Sorry about that. Adapter 3, you're going to check Enable Network Adapter, Internal Network, and yours will probably not come up already filled out like this, but put the number 2 in there. So it'll say intnet 2. Then click on OK. Then we'll start our pfSense server. And we can see our WAN IP address and our LAN IP address. You can see our WAN IP is on the one I mentioned, 192.168.254, and specific IP, the host IP is 138. And the LAN IP is 192.168.1.1, which is default for a brand new firewall. So in the next lesson, we'll start setting up our Linux Mint machines on the internal and the DMZ networks. Welcome back. In this lesson, we're going to download and install the first of 2 Linux Mint servers. This one will be for our internal network. So just go to linuxmint.com and click on Download. I use the Mate version, 64-bit. So just click on 64-bit under Mate. Click on the World site or a location that's close to you and let the file download. I'm going to close this because I've already done that. In VirtualBox, click on New. Give your new virtual machine a sensible name so you'll know what it is. You can leave Ubuntu 64-bit selected because Mate is based on Ubuntu. Click on Continue. Change your memory to at least 2048 or 2 megabytes if you can. If you have enough memory, your virtual machine will run better. Create a new hard disk now. Virtual disk image, dynamically allocated so it will grow as needed instead of just take up all the space at once. Make it at least 20 gigabytes. Remember, this will grow as you need it, so it will not take up 20 gigabytes of space unless your machine grows to that size. Click on Create. You're going to have to change a few things before you start this VM. So right-click and go to Settings, or have it selected and go to Settings up here. Under Storage, go to the controller and browse to your Linux Mint ISO you downloaded earlier. If it's not listed here, it probably won't be. You'll click Choose Virtual Optical Disk File and you'll browse to that wherever it was downloaded, probably in your Downloads folder. And under Network, choose Internal Network and IntNet. So this is the first of the 2 internal networks, and this is the corporate network behind your DMZ. Make sure Enable Network Adapter is checked, and then click on OK. And double click to start the virtual machine. And this will start the installation process. Click Enter to start Linux Mint. And Mint will start in live CD mode. So we're going to want to install Linux Mint. You can see the icon for it right here on the desktop. Double click that icon. And most of this will be defaults. I'll tell you where it's different. Select your keyboard layout if it's not English US. I select this in case it's needed. It just means it will install licensed software if it needs to for drivers. Click on Continue. I also check Use LVM, which is Logical Volume Manager, because it's easier to resize hard drives if you have to later on, if you check that. I don't usually encrypt for, especially for lab virtual machines. And click on Install Now. Click on Continue. It already has our time zone selected, my time zone. Select yours if it's different. You just click where you want it. And click Continue. I like to make the VirtualBox name, the computer name, the same as my virtual machine name. This is up to you, but just please make it something that you'll understand if you're SSH'd into the system. It can get pretty confusing if you don't select a sensible name. And I leave require my password to log in checked or selected. And I don't encrypt my home folder for a lab environment. Click Continue. Once the installation finishes, just click Restart Now to restart. It should take care of removing that ISO image from the virtual CD player for you, so just press Enter. Log in with the username and password you used at startup. You can read through these things if you'd like. There's some useful information there. But I usually just uncheck this and close. Okay, we can get to our firewall, but we can't get out to the internet yet because we haven't configured a DNS server on the firewall. We'll accept the risk and continue for the HTTP certificate. Just admin and pfSense for the initial login. Then we're going to change the password, of course. And that's it for this lesson. We'll do our initial configuration of the firewall and get it set up for the DMZ in the next lesson. Welcome back. In this lesson, we'll continue configuring our firewall for the DMZ. I'm configuring DNS on this firewall because I started with a clean build for this lesson. You won't have to do that if you're using a firewall that's already up and running. It's much nicer to configure the firewall through the nicely designed web GUI, so we'll use that. First, we'll create a DMZ interface. From your menu, choose Interfaces and Assignments. You can see there's one available network port that has not been assigned. Click Add. We'll change the name from Opt1 to DMZ. And we'll check Enable Interface. We'll choose a static IP version 4 for configuration type. And we'll set the IP address at 10.0.0.1, and we'll use a 24-bit mask. That's a Class C subnet. This is a private network, so we don't want to block private networks, and we won't worry about bogons at this point. Click Save. Apply changes. And it says the changes have been applied successfully. Now if we go back to interfaces, assignments, we can see the DMZ interface is assigned. I'm going to go to Firewall General Setup and make sure we have DNS servers. You'll already have this if you're not starting with a clean config the way I was for this lesson. And we'll click on Save. Now we'll configure some firewall rules. When you first configure a new interface, it comes without any rules, meaning no traffic can flow on that interface. So we'll go to Firewall, Rules. We'll click on DMZ, and you can see there are no rules at all. We'll click on Add. We'll leave the action as Pass. Interface is DMZ. Family is IP version 4. We'll leave it as any source. You could specify your individual servers in here and say what your individual servers are allowed to do on the outbound. Destination is any. We'll select DNS for the protocol. Actually, the protocol is going to be UDP. Source will be DMZ net. Destination will be any. I'm going to go ahead and log packets. We do want to know what DNS resolutions are happening. And give your rule a name that makes sense. I'm calling this DNS outbound from DMZ. Click on Save. We won't apply changes yet because we'll put in a few more rules first. If you want to add a rule above an existing rule, you click the Add with the up arrow. If you want to add one below, you click the Add with the down arrow, and we've already covered this in the Rules section. But you'll want to put the more used protocols higher. They'll be hit first, and they won't have to go through the list looking for the right hit. We'll add a rule below for Network Time Protocol, or NTP. Source will be DMZ network again. Protocol is UDP. And we'll choose NTP, port 123. We'll save that. We'll add another rule at the bottom. It shouldn't be used very often, and it's really just for testing. And we're going to allow ICMP, which is Internet Control Messaging Protocol. And that's what you use to ping. Source will be DMZNet. Destination will be any. Protocol is going to be ICMP. We could specify echo requests and replies, and that is the safest way if all you want to do is echoes, because there are other types of things you can do with this protocol that we would not want to allow. But this is just for testing, so we're going to leave it. And we will log these packets. And click Save. And apply changes. Next, we'll set up our second Linux Mint machine, and that'll be acting as a server. We'll install Nginx on that. Welcome back. In this lesson, we're going to configure our second Linux Mint to be our DMZ server. Linux Mint is actually a desktop operating system, but it doesn't matter. We can configure it as a server, which we're going to do in this lesson. A lot of the steps are very similar, so we're going to kind of fast forward through those and focus on the differences. Pick a practical name for your server. Remember 2 gigs of memory. Disk size is 20 gigabytes. Under settings, again, you still have to pick your ISO image. And under networking, we want to choose internal network and make sure you choose IntNet2. That'll be the DMZ network. And we'll power on. Double-click Install Linux Mint. Install third-party software. Use LVM. Because we have static networking on our DMZ, we'll keep getting this warning until we configure networking. So don't worry about that. We'll click Restart Now. Press Enter. Click on Menu and Control Center. Scroll down to Internet and Network and Network Connections. Click on the Wired Connection 1. And and then go to IPv4 settings. Select Manual, Add, and DNS servers. And those will just be separated by a comma. IPv6 we'll set to ignore. You could see when I clicked add, it put an extra line in there. We had to delete that to get saved to be available. So click save. And we now have a network connection. Let's see if we can ping our gateway. And we can. Let's see if we can resolve a name on the internet. And we can. And we can also ping and get a reply. So this means DNS is working and networking is working. Let's see if we can do updates. And that's not working. Why do you think that would be? We haven't allowed that on our firewall yet. So let's take a look and see what we need to do on our firewall. See how we can figure out how to add the right protocols. So it couldn't connect to anything. It gave us a whole bunch of errors. Now we're back on our internal Linux Mint installation. And we're going to go to Related Log Entries. We should see a bunch of failed traffic here. Looks like it's trying to use port 80 for all of this. So let's see if we allow port 80 if updates will work. Go back to Firewall, Rules, DMZ, and we'll add a rule for port 80. It's going to be TCP, HTTP. Oh, source, we'll do DMZ-net. We're not going to log these because it will probably be quite a bit of traffic when we're doing a download, when we're doing updates. And it's going to be HTTP outbound from DMZ for Linux updates. We'll click Save, Apply. Now we'll try again. And look at that, we get updates. I like to upgrade my servers as soon as I build them so I don't have to worry about any vulnerabilities that could be exploited. Not long after I did this, updates stopped working. I had to add a rule for port 53 inbound on the WAN from the DNS server 8.8.8.8. And once I did that, it worked fine. You may or may not have to do that. Please look at your firewall logs if something's not working and figure out what you may have to change to fix it. In the next lesson, we'll install Nginx, a web server, on our Linux Mint DMZ build. Welcome back! In this lesson, we'll install Nginx on our Linux Mint computer in the DMZ. First, we'll make sure updates work. If updates don't work, please troubleshoot until you get them working. Then we'll do sudo apt install nginx to install nginx. There are a few commands you'll want to know to manage your Nginx server. Sudo service nginx status will tell you the status of your server. It looks like it's running, so we'll do a test. You can just type localhost in your browser and it'll take you to your Nginx startup page. So we can see that it's running. You just type Q to get out of that little status page. You type sudo service nginx stop to stop Nginx. Now if we refresh, it won't work. And sudo service nginx start to start it. And it's back. So that's really all there is to it. You've got Nginx installed, and in the next lesson, we'll allow Nginx inbound to the DMZ on the firewall. Good job. Welcome back. In this lesson, we're going to configure the firewall so it will allow inbound traffic from the internet to our web server. We'll do this using port forwarding. So we go to Firewall, NAT, and under Port Forward, we'll click the Add button. The interface is going to be WAN, protocol is going to be TCP, the destination is going to be the WAN address. This is going to look like it's coming into the WAN address. We'll do HTTP. And looking back at our web server, we see that its internal IP is 10.0.0.10. So we'll enter that as the redirect target IP. Redirect port will be HTTP. Description is HTTP inbound from internet. And don't worry about NAT reflection, but we do want to add an associated filter rule. This rule will be linked with this NAT entry. So if we make changes to this NAT entry, in the future, it'll also change the associated firewall rule. So we'll click Save. and apply changes. And then we want to look at the IP address of our firewall, the WAN address. And it's 192.168.254.138. So if we go to that IP, we should get our Nginx page, our Nginx default page. It doesn't appear to be working yet, so let's take a look at our logs. So because we're using an internal IP address scheme on our WAN port, one of our rules is conflicting. It's saying to block private networks from WAN. So we're going to have to tell it not to do that. So we go to Interfaces, WAN. And down here where it says Block Private Networks, we'll uncheck that and click Save. Apply changes. And it works. Now we can get to this IP from our host, which is simulating the WAN. Next, we'll learn how to protect our web server with Snort. Welcome back. In this lesson, we're going to protect our new web server in the DMZ with Snort. I must admit, it was a lot easier than I thought. I hadn't done this in quite a while, and it's pretty straightforward. To monitor an interface with Snort, you go to Services, Snort, Snort Interfaces, and if your WAN interface isn't here or you have no interfaces defined, you just click Add and add your WAN interface. Now once you add Snort to the interface, it will not yet be started. I did a fair bit of troubleshooting before I figured out I hadn't started Snort on that interface. I was wondering why it wasn't catching anything. So remember to start Snort on that interface. Now we'll do a quick test to make sure Snort is going to stop my attack. And Snort should be configured the way you had it configured for the previous lessons. Just make sure blocking of offensive source IPs is allowed, and I'll review that in a minute with you. So first we'll make sure we can get to our Nginx server in the DMZ, and there it is. Then we'll run a tool called Nikto. Nikto is a free web scanner. You can download and run it yourself. I'm running a Kali Linux virtual machine, which is designed for pen testing, so it has lots of tools for this. So let's see what happens when we run Nikto. First we'll do it with the Snort stopped and see what it looks like. Nikto is a pretty cool tool, by the way, to test your own web servers and make sure they look secure. Oh, I was blocked from before. So I'm going to remove that IP. Make sure our web page is up. And try again. There we go, that looks better. It takes a few minutes and it runs a lot of tests against the web server, and it will report suspicious things or misconfigurations back to you. Okay, it sent 7,915 requests. It had 0 errors, and it only had these 3 items. Anti-clickjacking X-frame option header is not present. The XSS protection header is not defined, and the X content type options header is not set. To make sure your Snort interface is set to block, click on Edit, and scroll down to Alert Settings and make sure that Block Offenders is checked. I personally recommend just blocking the source IP. Then make sure you click Save and Apply and you'll be good. We'll turn Snort protection on by starting it. And then we'll try again. It takes quite a while to time out. We'll come back to it. But let's look in our Blocked tab, and we can see it saw that it was trying to do a webroot directory traversal attack, and it saw an unknown method, and it blocked it. And it takes quite a while to run and time out, but it said there were 20 errors, and it finally timed out. It gave up. So it looks like Snort is working and is protecting our web server. Welcome back. Now that we have the DMZ configured and a web server running on it, you want to be able to manage your web server from the inside or corporate LAN. A straightforward way to do this is to have your web server in the DMZ listen for SSH connections on a port other than port 22. TCP port 22 is the standard port for SSH. If you have servers you manage on the internet, you'll likely want to be able to do that on port 22. If you redirect all port 22 traffic to the server in the DMZ, you'll no longer be able to get out there and manage those other servers. All port 22 traffic from the LAN would be redirected to the Nginx server in the DMZ. An easy way around this is to configure the server to listen for incoming connections on a different port. We'll do that now. Get on your DMZ server and go to the command prompt. We'll start by installing OpenSSH server. To do that, just type sudo apt install OpenSSH server -y. Put in your password if you're prompted. And OpenSSH server will install. Once SSH server is installed, you can change the default port to a port of your choosing by editing the etc ssh sshd_config file. First, we'll make a copy of that file. We can see we only have one copy of it. We don't have any backups yet, so we'll make one. Sudo cp sshd to sshd.0. And we see our backup is there. If you already had a .0 file, you could save your new one as a .1 or increment the numbers as appropriate. Once you've made your backup, edit the sshd config file. If this is a default install of Mint, you may have to install Vim first. You just do that with sudo apt install Vim. I've already installed it, so that's done. So to edit the sshd config file, it's sudo vim sshd config. Just scroll down to port 22, remove the pound sign or hash mark in front, type I for insert, and add 2 2s to the end, so it's port 2222. Hit escape, colon, WQ for write and quit. And now if we do a diff on the original file, and our edited version, you can see the only change is removing the pound sign and adding 2 2s to the end there. So port 2222 is now the port your server will listen on for SSH connections after we restart the SSH service. But first we're going to have a look at some commands to manage SSH. So type system control is enabled SSH, and it should say enabled here. If it doesn't, you just type sudo system control enable SSH. It's not going to do anything for us because we've already got it running, or enabled, but that's okay. And we also want to see if SSH is active. So you type system control is active SSH, and it should say active. And if it doesn't, just type system control start. You're going to have to do sudo for this, or you'll be prompted for a password. So we got prompted for a password because we didn't type sudo. And it starts it. But what we're going to do now is restart SSH to make sure it's listening on port 2222. And finally, we can look at the status of SSH. And you should see a line in here that says active, active running, and then the uptime, the start time. And it also tells us what port it's listening on. So let's test SSH. The command to do that is SSH, your username, at localhost, -p, and then the port number, which is 2222. You don't really have to have your username in front if you want to log in as the same user that you're logged in as. In other words, since I'm logged in as Theo, it would assume that I want to log in as Theo if I don't put that in there. You'll be prompted to accept the fingerprint the first time you log into the server. And then you'll be prompted for your password. And we're logged in. So SSH is working and listening on port 2222. Let's test sudo permissions while we're here. And we have sudo. If you didn't have sudo, you would type sudo usermod -a capital G sudo group and the username. And it was already there, so it didn't make any changes, but that's what you would type. And then you would again test to make sure it works, but we're all set here. So that's it for this lesson. Good job. In the next lesson, we'll configure the firewall to pass TCP traffic on port 2222 to the web server in the DMZ. Welcome back. In this lesson, we'll configure the firewall to forward outbound traffic from the LAN on port 2222 to the Nginx server in the DMZ. To do this, go to Firewall, NAT, and we'll add a port forward rule, but we'll have it go below the existing rule. The interface will be LAN, protocol will be TCP, destination will be the LAN address, destination port will be 2222, and the redirected target will be the IP address of our web server. Which is 10.10.0.10. And the redirect port will also be 2222. And we'll leave Add Associated Firewall Rule selected. Click on Save. And Apply Changes. And since we're on the LAN, we see 192.168.1.1 is our LAN IP address. So we'll type SSH tedl or your username at 192.168.1.1 minus p2222. And we're in. My username on the other server is actually Theo, so I had to change that, but we're in. In this lesson, we'll talk about troubleshooting. If you have your firewall long enough and you do enough with it, eventually you're going to run into an issue. Troubleshooting in general relies heavily on gathering as much information you can about an issue and then searching for an answer on the internet, asking a question in a forum, or opening a case with technical support. Even if you have paid technical support, I recommend troubleshooting in the order I present. If you're an experienced troubleshooter, you have your own methodology and can try whatever you want. Use your own judgment about when to open a case if you have paid technical support, but realize that it takes time to get a ticket open and to get someone helping you. The quickest and easiest resolution to an issue is often found by locating a blog post or forum discussion that already exists about the particular issue you're experiencing. If you want to ask a question in a forum, be sure the same question hasn't already been asked and answered on that forum first. Use the forum's search feature to check this. Open a case with technical support will likely result in a few hours of your time, even if the issue is ultimately an easy fix. Here's one example of troubleshooting a minor issue with my pfSense SG1100. I was trying to set up a rule to block some snort alerts that are noisy but weren't adding much value, and I got an error message. It said, suppress list LAN support and some number is defined for this interface, but it could not be found. The error message leads me to believe some file was supposed to be created when I tried to create this rule, but it wasn't created for some reason. So what's the quickest fix? Well, following our rules, first thing we did was search for the answer on the internet, and it came up pretty quickly. The recommended solution worked well for me, but there was an additional step. I had to assign the new list to an interface. So I posted a new answer to this post on the forum for anyone else who may be having the same issue. I don't have paid support, so my other option besides a Google search would have been to post a question on the Netgate forum. The first response probably would have been, Why didn't I use the search feature and find out that the answer already existed? But even if it wasn't there, if it were a new issue, I would have to wait for someone to respond. And if you have paid support and you open a support ticket, in my experience, even a fast response will take you about a half hour total. You have to call or email. You have to provide information about your support contract. You have to provide information about the issue, and you have to wait for someone to research and get back to you. Chances are very good that if you're experiencing something, it's not the first time in history that anyone's experienced this, and also are very good that if someone else has experienced it and resolved it, you may find an answer about it on the internet. Section 7.9 of the pfSense book is devoted to troubleshooting. Here are the topics covered in that section. It tells you what to do if you cannot access the web GUI from the LAN. It tells you how to troubleshoot having no internet from the LAN. Discusses some WAN interface issues, some DNS resolution issues, client gateway issues, firewall rule issues, and NAT issues. So if you have trouble with any of those things, check the pfSense book before even searching the internet. When troubleshooting, stay calm. I know that sounds easy, but when you have everyone from the CEO on down yelling at you because the internet's not working and it's costing you money, it may not be easy, but you have to do it. Just have confidence, stay calm, and you'll figure it out. Roll back any recent changes you may have made. If that doesn't work, gather the information you're going to need and search. Things to find for your internet search are your pfSense version, specific error or log messages, a description of what you were doing or why there's a problem, and your hardware information if applicable. That's it for the troubleshooting lesson. Hopefully you won't need to troubleshoot very often, but you will get better at it with practice. In this lesson, you'll learn how to back up your pfSense firewall and restore it from a backed up file. To do a backup, just go to Diagnostics, Backup and Restore. Depending on what packages you have installed, you might check Do Not Backup Package Information. And if this is for work, you might consider encrypting. You would encrypt by checking this box, and then it will ask you to input a password. We're going to leave it unencrypted. I leave Do Not Backup RRD Data checked. RRD data is used to present analytical data graphically. And we are going to back up package information. You could pick a whole bunch of different areas to back up. We're going to back up everything. So this will let you download a configuration file as an XML. Select Save File. And it looks like it backed up. And then to restore from a backup file, you would just browse to it, highlight the file you want, click Open, and then click Restore Configuration. Are you sure you wish to restore the configuration? Click OK. And it will restore and then reboot the firewall. So that's how easy it is to back up and restore your pfSense firewall. And I definitely recommend backing up before and after any major changes. In this lesson, we'll learn how to update the pfSense firewall software. If you have your default system information page in the web GUI, version information is there right under the BIOS information. So you can see it says that my system is up to the latest version. If that weren't the case, it would tell me an update is available here. And I would go to System, Update, and then there would be a button here to allow me to update. I would just click on that and update, and then it will reboot the system if necessary. I've never heard of an update breaking things in pfSense, but you don't want to risk it unless you have a recent backup. So do a backup before updating, and it's good practice to back up frequently anyway. That's all it takes to keep your firewall up to date. Good job.